Mhm. Hello, hello, welcome everybody. Come on in. Welcome to Letterform Lectures, online edition. Okay, people are joining us. Let's give them a few more minutes. People, when you log on, do us the favor of telling us where you're coming from in the chat. And you can also tell us why you're here. So put that, just drop a little line in the chat so we can get a sense of where our international audience is coming from and what brought you to today's lecture with Mike Hudson. Okay, well, keep the doors open as people join in. Got one person, okay. Yeah, drop it in the chat and then also pull down the little blue lozenge to say everyone, if you want everyone to see your chat message, not just me. All right, well, let's get this show on the road. Welcome to Letterform Lectures. My name is Grendel, and I am Education Director at Letterform Archive, which is also the home of Type West, our School of Type Design. I'd love to give a massive shout out to Letterform Archive's Scilla Zaccolini, who is the mastermind in the background of this lecture series. So thank you, Scilla. Woo! And just a quick reminder that we need to mask up. Pandemic's not yet over. Best way to prevent its spread is by masking. So mask up when you're indoors and please stay healthy, everybody. And while you're rolling in, I see some people dropping where they're coming from in the chat. That is awesome. And it'd also be nice to let us know why you're here. So what brought you to the lecture today? We're curious. Okay, Letterform Archive is the home of Type West. We offer a year-long postgraduate certificate in type design, and we have an online and an in-person program that's held at Letterform Archive. And our application window for 2023 opens up on October 1st and will close on November 2nd, which is the Day of the Dead. So if you are considering applying and you'd like to learn more about our program, either the online one or the in-person one, please don't hesitate to get in touch. Email us and we will either set up an appointment or send you more information and answer any questions you might have about the program. Okay. Well, if you're in the Bay Area, make an appointment to come see our new exhibition, which is Strike Through. The gallery is open from Thursday to Sunday. This fantastic exhibit was curated by Silas Monroe and our very own Stephen Coles. And this timely exhibition of protest graphics will make you want to grab a stencil or some collage material and whip up a couple of hard-hitting posters to take out into the streets yourself, because you know, some things have been happening lately that you might want to complain about. So if you don't think you have those skills, no worries, we've got your back. Internationally known radical artist Fabiana Rodriguez is leading a collage workshop for us in art and social justice graphics that you can sign up for. It is one day only, September 17th, all day. We also have a couple other online workshops coming up. Our very own Stephen Coles and Christopher Sly are putting this crash course in type selection online. It's everything you wanted to know about choosing type, but we're afraid to ask. So this top team of type experts will get you on the path to great type choices. They'll give you tips on how to organize and better use your type library. This workshop is for beginners and pros alike. You will all benefit. We also have popular instructor Lin Yoon returning to school us in the art of flourishing, which is not actually a result of happy accidents. It is easily doable with the right training. So in this workshop, you will learn how to identify the basic elements of flourishing and dissect what makes good flourishing pleasing to the eye, and ultimately combine the elements to create your own cool flourishes. So for more information about our upcoming Letterform lectures, which will start up again in the fall, our salon series, and any other upcoming workshops and events as they happen, go to letarc.org/events. And better yet, become a member of Letterform Archive. Sign up today at letarc.org/join. You stay in the loop, you get cool perks, and you help support this great lecture series. Finally, you can follow us on Instagram to stay on top of events and programs. Follow at Letterform Archive or at TypeWest. Okay, welcome to Letterform Lectures 2022. Letterform Lectures are co-presented by the Letterform Archive and SFPL Main Library. Letterform Archive is a nonprofit institution housing over 85,000 works of graphic design history. We love letters and we love people who love letters. Graphic designers, type designers, printers, calligraphers, lettering artists, graffiti writers. You're all welcome in our big house. We'd like to thank Adobe for generously sponsoring the video recording of this lecture series. You can view all Letterform lectures online soon after they happen. Just check our website, letterformarchive.org. Okay, here's today's topic. In this Letterform lecture, Mike Hudson will lead us on an exploration of the surprisingly complex history of printing and embossing for readers who are blind or visually impaired. So Mike Hudson became the director of the Museum of the American Printing House for the Blind in Louisville, Kentucky in 2005. He received his MA in the history of technology in 1987 from the University of Delaware, and he has spent the last 35 years working in museum collections and exhibitions. So I was intrigued by the unusual spelling of Michael's first name, so I asked him how it was pronounced. I always do that anyway, and he explained that his mother wrote it that way on his birth certificate because that's how she spelled it. So it's been that way, and he's been fielding questions like mine ever since then. So we're honored to introduce Mike Hudson today.
Thank you, Grendel. Thank you very much. And I will share my screen here. And we'll go to the first slide here from the beginning. There we go. Thank you very much, Grendel, for that kind introduction. I'm very glad to be talking to you all today. I talk a lot about history of education for people who are blind, education and rehabilitation. And of course, at a place like the Printing House, we have a really outstanding collection of tactile books and tactile printing equipment, and tell the story to thousands and thousands of guests every year. So I just want to tell you just a little bit about the company. It was founded in 1858. We moved into our current building, the current site of our building. It's now more than 14 different structures, but we moved here in 1883. And the museum opened in 1994. And initially it was kind of stuff that almost like glacial till that had washed up at a company that was as old as we were. And somebody, said, "Hey kids, we should put on a show. Let's open a museum." But since then we have gradually grown until our collection really is one of the finest collections of its kind in the world, and certainly in the United States. And so what I'm going to do for about the next 45 minutes is walk you through kind of a quick history of tactile books. We're not really going to talk about large print books or even, the print equipment, the general ink printing equipment that we've used at the Printing House over time, because there's just not enough time. So that might be another seminar somewhere down the road. So without further ado, the tactile book, Embossing Systems for Blind Readers. So let's talk a little bit about prehistory. Before modern times, people with disabilities, and in particular people who were blind, were often considered to be cursed by the gods, that you or your family had done something in the past that caused you to be punished. And if we look, one of the more ironic things about early writing is that if we look at early writing forms, and I have slides up that show some early Sumerian cuneiform and then some Egyptian hieroglyphics. But if you look at the Incans or the Mayans or the Greeks or the Assyrians or any of the early writing styles that survive, they're all tactile. You can feel cuneiform. You can feel hieroglyphics. If the Pharaoh had decided that he wanted his early citizens to be able to read, it would have been possible to teach them, but of course they were not, because education was denied to people with disabilities because they were considered to be unworthy of education, right? But it wasn't just people with disabilities. Ladies, I'm sorry, all of you were out as well. You were not considered to be, worth educating. Or if your skin was the wrong color in a certain society, if you weren't the member of the priestly caste or the right economic caste or the right social class, you didn't get to be educated. So the first thing that had to happen before anything that could be developed to explore what was possible for people who were blind was there had to be an attitude change about who was worthy of an education. So that starts to change for the first time in France, in Europe, in 1784, when this man, Valentin Aoui, founds the first school for blind children anywhere in the world. And Aoui had a kind of a epiphany on the streets of Paris in 1781 when he had stumbled into a street tavern where a number of blind people had been paid by the proprietor to dress up in clown outfits, essentially, and play musical instruments badly and be mocked and be laughed at. That was basically their job. And that would, of course, attract people into the tavern to where they would buy drinks. And Aoui looks at this and thinks to himself, surely there's got to be more, better, meaningful employment for people who are blind or visually impaired than what I'm seeing on the streets of Paris, where most are beggars. So Aoui founds the first school in 1784. Initially, he has one student, a kid named Francois Lesueur. And it's Lesueur's job to pick up the school's mail every day. And every now and then, Dr. Aoui gets an invitation from the French court. He has gotten a side gig as an interpreter, an official interpreter for the King of France. Every now and then he'll get invited to some fancy soiree. And Francois Lesueur notices that every now and then some of these envelopes, he can feel the print on it because they are embossed. Even today, we make a wedding announcement or a funeral announcement or a graduation announcement. We make it fancy by sending it to the printer and asking for it to be embossed. And this gives Aoui the idea to create a special type font and invent a process where the kids at the School for the Blind, the Royal School for Blind Youth in Paris, can emboss their own books. And the first production of that press comes out in 1786. This book, this is a couple of pages from that book, which is what we call the essay on education for the blind. And if you look at the font, it's a highly serifed font, a pretty complex font. If you were trying to design a font today that would be clear just visually, you wouldn't pick this font. But this was the font that we decided to use, and he was able to demonstrate that you could teach. He taught Francois Lesueur and the other students at the school not only to be able to read this raised type by touch, but also to produce books in it, to set the type and emboss books there on their own equipment at the school. And a curious thing about this is an experimental book, right? It's the first raised letter book, the first book for blind readers of its kind. And I've seen 5 copies of this book. We have one in our museum. And in every one of them, it's bound very tightly at the spine. Very typically, it's stitched, very just the same way that any book of its type of its age would have been stitched. It's too tight, and so all of the relief on the pages has largely been flattened out because it's an initial experimental book. They didn't know what they were doing. Later on, when you look at books that come after this, the spine is much fatter than you might expect it to be on a book because they have bound spacers in between the signatures of the individual signatures of the page at the spine, so that the pressure on the embossed lettering is much less, and so the lettering lasts a lot longer. So IWE's idea soon starts spreading around Europe. And up here on the page, I have a couple of examples by a couple of Scottish inventors, one by James Gall in 1831, that's on the left. And his font was kind of a triangular, it's sometimes called triangle print. And you can see that it involves lots of angles. It's very angular. So the B is a very odd looking B with no closure on the top. The A is actually a triangle facing to the left. And it almost looks like what the dwarves used in Tolkien's Lord of the Rings, right? And then on the right is another Scotsman, John Alston, from 1832, and his is all caps, very clean, pretty nice design, very easy to read by sight, and he's just using all capital letters. So these are all systems, Awi, Gall, Alston. These are all systems that are based on Roman letters, right? So some other inventors look at Roman letters and they see that it is somewhat difficult, especially for people who have lost their vision later in life. For little kids, not that big a deal. You teach it to them and they pick it up pretty simple. But for older people who've lost their vision later in life, these alphabetic systems don't work so good. So a guy named Thomas Lucas, that's on the left, in 1833, he invents a typographic system based on a popular shorthand system used for taking courtroom notes and for doing dictation. And he comes up with his own alphabet. And then the system on the right is the Moon system. Both of these are from Great Britain, from England. And William Moon invents his system in 1845. Moon was one of these guys who had lost his vision later in life. He had started teaching some kids that were blind in his neighborhood, and they were having trouble with the Alston and the other alphabetic systems. And so Moon, his system is kind of a hybrid between an alphabetic system and an arbitrary system. Arbitrary, where you just assigned the most tangible characters to the letters rather than something that looks like the actual Roman letter. So on Moon's system, I've got the key up here. And so you can see is that the A largely looks like an A without the crossbar. And the B also looks like a lowercase b, but it's not all the way closed. The C looks pretty much like a C. But the H, the G, they look nothing. The H is actually a small circle. The M is just an angle. It looks nothing like an M. So, and then the numbers 1 through 0, they're exactly like the written Arabic numerals. So it's kind of a hybrid system. Again, he's going for tangibility rather than being something that looks just like the original print. And there's a big debate here because a lot of educators for the blind, the ones that favor the Roman letters are basically saying, look, how can it be fair if our blind kids are not learning the same system that sighted kids are? So they're talking about in terms of equality. The folks who are in favor of the arbitrary systems are saying yes, but those systems are not very tangible to the finger. You're speaking to the finger in the language of the eye. And so these arbitrary systems we think are more tangible. So then in comes Louis Braille. So Louis is born in a little village outside of Paris, France in 1809. He's not born visually impaired. He's sighted, but he has an accident in his father's leather working shop in when he was about 3 or 4, and his eye gets infected from the cut. And if you don't know, your eyes are connected through your tear ducts. Today, if it happened, they would shoot you full of antibiotics, and 6 highly trained eye surgeons would descend upon you and fix you. But Louis lived in 200 years ago when there were no antibiotics, no real understanding of germ theory, and no eye doctors. So his eye got infected. He lost his vision by the time he was 5 or 6. But he lived in the only country in the world, France, that actually had a school for the blind, Dr. Aoui's school, and Louis was lucky enough to get to go there. And he was a sharp kid, such that when around the time he was 12 years old, he was introduced to a dot code that had been invented by a guy named Charles Barbier. And through the outstanding research of a Canadian researcher named Philippa Campsie, we have learned a lot more about Barbier. Most of what has been published about Barbier in the past has been false, has been nothing more than just folklore that's been repeated by one author after the other. But we now know from Philippa's work that Barbier is this really interesting guy. He's often described as a soldier, but Philippa's research has told us that he was really only a soldier for just a few days, and ended up having to flee the French Revolution, lest as an aristocrat he have his head cut off. So he and his brother fled to the United States, tried to get a job working for George Washington, failed that, and ended up, coincidence of coincidence, teaching French and surveying at Transylvania University in Lexington, Kentucky, which is about 70 miles east of here. And then in 1803, the Emperor Napoleon issued an amnesty to all the former aristocrats, and so Barbier was able to return home. And he had invented this system that he called night writing, which used a system of dots, up to 12 dots, 2 columns of 6 dots high. And instead of basing his code on the alphabet, he based it on the phonetics, the way we pronounce words. So Barbier had come up with a simple way to write this dot code. And when Louis Braille and his fellow students at the School for the Blind in Paris discovered the Barbier code, they loved it, because for the first time they had something that they could actually take notes on. They could take notes in class. That was one of the big problems with raised letter systems and those arbitrary systems I showed you before, Lucas and Moon. You couldn't write them. But you could write Barbier's code. But Louis quickly realizes that there are some significant flaws in the Barbier code. The 12 dots take up too much space. They're slow to write, and they don't fit right underneath your fingertip. And because they're based on phonics, you cannot learn to spell using the Barbier code. Although later Barbier did develop an alphabetic system, a system of his writing thing. And so Louis, between the time he's 12 and 15, he redesigns the Barbier code down to the 6 dots that we use today. And he based it on the alphabet and came up with a whole punctuation system and a capitalization system and a numerical system. And he publishes his code for the first time in this book, what we call the Procede, basically the method for writing music, words, and plain chant by means of dots. Publishes it for the first time at age 20 in 1829. In this book, we have one of the 6 remaining surviving copies of this book that are left anywhere in the world. We have one in the museum, and it's a wonderful, amazing artifact. The paper is just this glorious cotton rag. And as you can see by looking at the front page here, you can literally see the outlines of the individual types that they used to set up the raised letter version of the book. And it was published in raised letters, even though he was introducing Braille, because raised letters, that was the system that was being used to teach kids. So if a kid at the school knew how to read, he knew how to read raised letters. And so the first thing Louis had to do was meet them halfway by having a book that would be the key between raised letters and his Braille system. And on page 14, as I have reproduced here, we have the beginning of the Braille code. And it's a very elegant system. It's arranged in rows of 10. So A through J, and then below that is K through T. And if you'll notice, so A is the top left-hand dot all by itself. B is the top left-hand dot and the second left-hand dot. Then go down to the lower row. K is just the top dot with the bottom left-hand dot added. So L is B with the bottom left-hand dot added. M is C with the bottom left-hand dot added. And if you go on to the next pages, the third row, which starts with U is A with two bottom dots added. So it's a very logical system. If I had you here, I could show you the whole thing, but it's a very logical system. And in fact, today in the United States, because we use the same alphabet that Louis used, our A, our B, our C is still his A, B, and C. And he was already thinking about how his system could be used, at least in Europe. And so in some of the lower ranks of his system, the 5th rank and the 6th rank, he's already including Braille symbols for the vowels, the glottal vowels that are used in German, and W, for instance, which is not used in French, but is used in English and German. And so that's a very influential book. Okay, so let's come across the pond to Philadelphia. So people see these ideas, these raised letter ideas. And the first raised letter book in the United States is done in Philadelphia in 1834 by a guy named Jacob Snyder. Again, you'll see as it's reproduced here on the left, a very highly serifed font. But that is really only one book ever done in that font. By 1838, Philadelphia had developed their own version of Alston's font, all based on caps. We call it Philadelphia Line from 1838. So the book on the left, this from the Select Library, is in all caps, the same as John Alston did in Scotland. In Boston, a guy named Samuel Gridley Howe, who's probably the preeminent educator of people that are blind in the 19th century, travels to Europe when he becomes the first head of the Perkins Institution in Boston, and studies the various fonts that have been developed there. And when he comes back, his font, which is called Boston Line Letter, introduced in 1835, as is reproduced here on the right, his font is very, very highly influenced by the Gall font, the very angular font. So we can see here that Boston Line Letter, the O is a diamond, the A is a diamond with a vertical line on the right. And notice the way he uses, well, the way he doesn't use descenders, right? So there are no descenders. So if you look at the Q, if you look at the Y, the line does not descend below the line. And so he has no capital letters here. Where he needs to use a letter that normally has a descender, like a P, he uses the capital version of it. So there's no capitalization in Boston Line Letter. Boston Line Letter becomes the most influential font in the United States, and with an adaptation I'm going to mention later, it gets used in lots and lots of raised letter books in the United States, including the very first one done at the printing house. So in New York, at the New York Institute, so the first three schools for the blind in the United States are in Boston, Philadelphia, and New York. And in New York, they're using raised letters just like everybody else, but their superintendent, William Waite, gets a hold of the Braille system, Louis Braille system. And he recognizes pretty quickly that the ability to write is a huge advantage for these dot systems. Think about the last time you had to study for a test. Writing is a hugely important part of taking notes in class and helping you to remember things that you have to recall later in a quiz or in a test. And so he has some of his students mess around with the Braille system, and he realizes that this writing thing is pretty important. But he's not all that fond of the Braille system. He likes dots, but he's not all that fond of Braille. So he comes up with his own American dot system that initially was called Waits Point, but now that we call it New York Point. And over there on the side, on the right side, is a raised letter key to New York Point. Waits system. So the Braille system is always 3 dots high, 2 dots wide, no matter whether there's 1 dot in it or 6 dots in it. It takes up the same amount of space. One of Waits' problems with Braille was that it was too bulky. And so he designed his system so that the characters are of variable width. They might only be 1 column long, or they might be as many as 4 columns long. And of course, the symbols that we use the most, he made, like the T, the T and the E, we use them the most. So they only take up 1 column, but the letters that we use least common, like X, takes up 3 columns. But he also came up with a system of capitalization and numerals. And by 1871, the American Association of Educators for the Blind had adopted the New York Point system as the official American point system. Back to Philadelphia. So in Philadelphia, they had been using their system, Philadelphia Line. And Samuel Gridley Howe in Boston had developed Boston Line. So in Philadelphia, there was a printer, a guy who was blind himself named Napoleon Nice Jr. And in 1868, he decided to combine Philadelphia Line with Boston Line because he thought it was unfair that blind kids were not learning capitalization. Remember that Philadelphia Line was all caps. Boston Line did not use caps. Because of its problem with descenders. And so Nice combines, so he uses capital letters from Philadelphia Line with the lowercase letters from Boston Line to create Nice's combined type. And by 1875, most of the printing most of the shops in America that were making raised letter books were using Nice's combined type. Now let's come back to the American Printing House of the Blind. So again, I'll remind you, we were founded in 1858. Because of the Civil War, we did not order a press until 1863, and we ordered it from the veteran press manufacturer and entrepreneur Stephen Ruggles, who had also designed and built the first press used for the Perkins School in Boston for Samuel Gridley Howe. And the picture on the left is of this cylinder press with a big, heavy metal flywheel. And it was hand fed, meaning that somebody sat there and fed one page at a time into it. Ruggles, very influential press designer, and designed some of the most influential early embossing presses for presses that served blind readers. We didn't actually get the press delivered until about 1865 at the end of the Civil War, and did not get it into press until 1866. And we only made a few copies of that initial book, and probably didn't make our first full edition of a book until about 1869. Interestingly enough, all of our first books were books of fables. The first 3 books we made were all books of fables. It's kind of interesting that, they could have, think of all the books that were that were available at the time. They could have made a math book. They could have made a science book. They could have made all these different textbooks, but instead they made books of wisdom. We could use a little of that sort of thinking today, don't you think? So now I have a picture of the APH press floor, a line drawing of it from about 1890. By this time we had 2 presses. In the very back of this drawing is the Ruggles press, and in the front is a press that was designed in Chicago by a guy named John Spencer. And it was a big double cylinder press. And then in the lower left corner of this drawing, you can see a little Baxter steam engine that powered all of the machinery in our early press floor through a system of belts and shafting. And you can kind of see the leather belts coming down from the pulleys and stuff that were overhead. have been a wonderful, wonderful and interesting place to go through. Unfortunately, we only have one photograph of the APH press floor before 1900. I can't imagine how a cameraman didn't come in and take a picture, but so far we've only discovered this one picture. So now I want to talk a little bit about B.B. Huntoon. B.B. Huntoon was our second superintendent. He started at APH in 1871. And he invented, his claim to fame while our superintendent, he was our superintendent for more than 40 years, was the invention of a way to make fairly inexpensive stereograph plates that could be fitted into these cylinder presses that we used. So basically what he would do is he had, we had type cabinets just like any print shop had. And the type was specially made, and they would set it up, using a shooting stick, and then lay it into a galley and sink it down. Once the page was constructed, they would sink it down into a tray of wet paper mache. And once the impression was made into the paper mache, they would fill that up with a mix of printer's metal. Just the same kind of printer's metal that you would use to cast type. It's got antimony and copper and tin. Let that set, and then they would peel that out of the paper mache, and they would adhere it to a piece of roofing tin. And so our picture here is of a completed embossing plate. This one is indeed to emboss an alphabet card, a key to New York Point, that dot code I talked about before. And you can notice that the plate is kind of curved. They are clamped into the cylinder on the cylinder presses we used during the day. And so all of the surviving plates still retain that curve, that signature curve. And the plates were not very hard, so they were not very durable. But the preparations of these plates were so labor intensive that the wealth of the company was really in the plates. Everything else could have been destroyed in a fire, and as long as you saved your plates, you could have been back in production pretty quickly. And so in 1905, we actually constructed a fireproof plate storage vault on the side of our building to store these plates. Now, the next kind of big advance comes from the fertile imagination of a guy named Frank Hall. Frank Hall was the superintendent of the Illinois School for the Blind in Jacksonville, Illinois. And in 1890, he invented the first successful mechanical Braille writer. And by about 1894, he had elaborated on the idea of the mechanical Braille writer, which wrote Braille onto paper, to come up with the Hall stereotype machine, which embossed the Braille onto copper embossing plates. So very quickly, in just 3 or 4 years, Hall had invented two critical machines, one that would allow you to quickly write Braille for yourself, take notes, write a book, whatever you wanted to do, but also quickly create these embossing plates that could be loaded into a fairly standard press and quickly mass produce Braille. And so the pictures are from the 1940s here, but it's a couple of ladies operating Hall stereotypers. And basically it's just a big metal frame and the women are sitting on stools, and on their left is a reading stand with the print book that they are translating into Braille, and they are expert Braille translators. And so they are typing the Braille translation of the print onto copper plates that are held in a frame inside the machine. And there's a Braille keyboard in front of them. And so one of these machines is set up, it's actually got an electric motor on it, the one on the left. The one on the right is foot powered. So the one on the left, when she presses the combination of keys, then she has to slam down onto the foot pedal to give the machine the power to emboss onto the plates. The one on the right actually is connected to an electric motor, and so it's powered. So that the stereotypers quickly make it much less inexpensive to prepare Braille embossing plates and give Braille a highly competitive advantage over both raised letter books and over New York Point. We're not really going to talk a lot about the whole War of the Dots here, but just know that in the 1920 catalog at APH, we were embossing and making books in raised letters and New York Point and Braille. And it wouldn't be until the 1930s that Braille would finally drive raised letters and New York Point from the field. So our next era here is the clamshell press. Now this is a row of presses that are variously made by the Harper's Ferry Armory or by Thomson Laureate, or they're sometimes called universal presses. And in their original configuration, they had lots of rollers and inking mechanisms up on top of them. But by about the 1930s, as the offset printing press and other types of presses started to take over ink press printing, these kinds of very nice, very high-end, highly accurate presses started to come on the market used, and APH started buying them. So in our photograph here, we have 3 young gentlemen standing behind these clamshell presses. Basically, as the flywheel on the side would rotate, the jaws would open, which would open up the hinged embossing plate that had been prepared on a Hall stereograph machine. And the young men would grab a page there from the table in front of them, insert it into the jaws of the beast. As the flywheel continued turning, it would close its jaws with great pressure and emboss 2 nice pages of Braille all at one time. And you didn't start out, working fast on these machines. You start out working slow. By about 1965, we had bought 19 of these old clamshell style presses and adapted them for Braille embossing. And in fact, when I started working here in 2005, we still had a row of 5 of them. And the whole plant, basically the heartbeat of the printing house in 2005 came from the constant thrum of these clamshell presses working. And it's still a little bit quiet here today because we haven't used any of them since 2017. And there's something quite missing without using the old clamshell presses. But we started using them in the 1930s. And then we have the rotary presses. So what we have here is a Bobst press, a rotary press that was actually designed about 1915 in Switzerland by the D. Bobst company. The Bobst was actually, it's an interesting, the press was actually invented originally for Braille manufacturing. It was a very high speed press. You could produce about 6,000 impressions an hour on the Bobst press. And it fed, you can't quite see it in this photograph, but on the lower left, there's a continuous roll of paper on a spool that feeds into between a pair of cylinders. And on one cylinder, you had the one of the metal embossing pages, and on the other cylinder, you had the other one. And so you could do, like 1,000 or 2,000 or 5,000 copies of page 1 of the publication. And then you would stop, change the plates, and you do page 2. And then it all had to be hand collated together. So the rotary presses were very fast and for doing high volume projects. And this one was used about 1936 by the printing house to do Reader's Digest magazine in Braille. And then later in the 40s and then early 50s, we actually completely stole the idea here at the printing house and made a couple of cheap knockoff copies of the Bobst press that we used up till about 2010 to make magazines. And as you'll notice, painted on the side of this one is maybe fingernail polish is the name Mr. Swiss. Some unknown operator has named her machine. And I guess when you worked with it every day, we did anthropomorphize things a little bit. Then we have our combo presses. This is a Kelly B press that was originally manufactured in the World War I era. We bought it used initially. We bought one in the 40s, and then we bought another one in the 60s. These, I call it a combo press because it could be used either to emboss Braille or it could be used in our ink print department. We did a lot of ink printing as well for our own internal purposes. And the Kelly was a press that could be used both ways. And this is a picture from about 1970 of the Kelly B. Then let's talk a little bit about computer Braille translation. So like when the picture that I showed you of the ladies at the hall stereotypers, they're basically translating the book as they type it onto the plates. But in the late 1950s, we did a collaborative project with IBM to computerize the translation process. So the two pictures we have up here right now, these black and white pictures, are of the initial system. It was a tape-based system. So on the right, you've got a Braille writer. That's a Perkins Braille writer that's been wired into this computer setup. And so the operator would have the print book there on the stand. There's a reading stand there. She would make the translation just like she would on the hall stereotyper, but instead it's punching this paper tape system that's over here on the left-hand side of the table. And that tape would be reeled up as she would punch that tape, the computer tape, onto it. Then that tape would be boxed up, shipped to New York. They would feed that tape into a mainframe computer. And then it would produce a second computer tape that they would ship back to us. And that tape would drive the little machine that's over here on the left. That's one of our old later model stereotype machines. And you can tell it's all been computered up, and it's got a nice little electric motor, and a bunch of relays have been built into it. And you hook it up to the same system, only now you're feeding the tape with the translation on it, and it would type. The paper tape would drive the translation, and it would type the Braille onto the embossing plates, and then the embossing plates would go into the standard presses that we were already using at the time. So then the next step happens in the 1960s when we move beyond the paper tape and we move to punch cards. So anybody who did any early computer programming, my wife still remembers them from when she was in school in the 80s. Here you have a row on the left of 4 ladies at key punch machines. These ladies need to know nothing about Braille translation. They don't know the Braille system at all. All they're doing is they have a QWERTY keyboard in front of them. They have the original book, and they're typing the book into the punch card machine, and the punch card machine punches the data onto punch cards. Then you take those punch cards to another machine, it loads it into the computer does the translation, another punch card machine puts out a bunch of punch cards, then those punch cards are loaded into a tray, into a punch card driven stereotype machine, and it makes the plates. Then the picture on the right is the next step, where there's no punch cards involved. It's all digital, and you're using magnetic tape. You have an operator. This is my next slide. You have a room full of young ladies. Again, they know nothing about Braille. They're just entering the book into the computer, and then the magnetic, that goes into as a magnetic tape into a big mainframe computer. Our computer actually caught on fire in 1977. It was a really bad day for us. Because you've heard about needing to refrigerate those big mainframe computers because they tend to get hot. And then the final step, and pretty much the way we do it today still, is over on the right here. And that's someone just typing the book into the computer, and then you use a piece of software, either Duxbury or Braille Blaster, to convert the digital print book into the Braille. And today, actually, no one has to type the book in. We just get a digital copy of the book from the publisher. We use Duxbury to turn it into Braille. And then the transcriber's main job is just to review the translation to make sure that it's all been done accurately. But in fact, you can do Braille translation on your cell phone. What can't you do on your cell phone, right? So once you have the Braille translation done, whether it was done with that paper tape or with key punch or today, then you can use a machine called the PED, the plate embossing device, that we bought initially from a company called Triformations in the 1980s. And we're still using these same two plate embossing devices to make any of our plate-driven Braille that we use today. And so my couple of pictures here are just of a couple of operators. And I think both of these pictures are from the 1980s, pulling a freshly embossed zinc embossing plate out of the PED. So the next kind of generation of presses that we used here at APH are the Heidelbergs. These are all presses that were originally invented as printing, embossing, and die cutting machines, very high end in Germany in the mid to late 1930s. And we bought our first one in 1975. It's over on the left. That's a Heidelberg windmill press. And then in the mid 90s and early 2000s, we bought 3 of the press on the right. Those are original Heidelberg cylinder presses. Extremely accurate, extremely reliable, automatic fed presses. And the windmill press and the Heidelberg presses are still used today for the windmill press we use for a project where you need to both emboss Braille and die cut or score. A good example of that would be flashcards. They can both put the Braille on there and they can die cut the flashcards that are then broken out of the card stock. And the cylinder presses are primarily used for magazines and other high volume projects. And we're still using those today. Wonderful, wonderful presses. But then we get into the digital age, and it started in 1987 when we bought our first digital Braille press. It was a TED 600 from that same company, Triformation Systems. This press was not very good. To get it to work, in fact, our engineers had to redesign it and put an air conditioner in it inside the chassis of the press because it constantly would overheat and jam. And in fact, this press had such a bad reputation that when I started in 1995 or in 2005, no one would tell me about it. I would see these pictures and I would wonder what it was. We didn't have it anymore. They'd gotten rid of it. And so so our first digital effort failed miserably, and no one wanted to talk about it. Then in 1993, we bought our first Braille press. And if you go in most Braille print shops in the United States today, the Braille is the primary machine. This is a Braille 200 over on the left. We bought our first Braille 200 in 1993. And it feeds, it's kind of a tractor fed press, but it's a digital press. So it involves no plates. The same file that you could use to drive a plate embossing device to create a Braille embossing plate can also be used to drive a Braille press to just create a paper copy. And then on the right is a picture I took just this morning of our line of Braille 650s, which is the highest speed, highest capacity Braille that's available right now. I think we have 6 of those on the floor. They feed their paper automatically off the big roll. The paper is about 80 to 100 pound, feeds in the slot into the back of that very uninteresting looking cylinder, and then raises metal pins on the inside to emboss the Braille. And both these presses are capable of interpointing, meaning they put Braille on both sides of the page. And largely when you walk back there, the Braillos are unattended. They're computer controlled. And so the operator will tell the press, make me a copy of this particular textbook using this file, and the press will begin doing it. And then we also have so the Braillers are made in Norway, but we also have a NV Interpoint 55 that we've had about 15 years. It's made in Belgium. It's actually the highest speed digital Braille embosser in the world. But other than that, it works a lot like the Braille. It feeds its paper automatically off the big roll and then raises pins on the inside. We're using our Interpoint right now to do our magazine line, which is another way of saying disposable publications that you only read once and then you might want to throw away. So let's talk just a little bit at the end about tactile graphics. One of the things that's always made APH unique is that not only are we able to emboss Braille, but we're also able to make tactile graphics. Now, our first real major tactile graphics project was in the 1890s. It was a cardboard atlas, maps of the United States. And the plates, as you see on the two plates examples I have here, were made out of copper, and they were hand tooled. So a craftsman with a special set of engraving knives and mallets would make the drawing by hand onto the copper plate. And then, as you can see, both of them have the curve that tells you they were used in a cylinder press to actually emboss the maps. Then by at least as early as the 1960s, we had come up with a more sophisticated tool, although it doesn't look that way here on the left. That is it is a plate tooling device. The more sophisticated version is on the right. That's what we call the Pearl, the plate embossing apparatus for raised lines. But whether it was what looks like just an assembly of odd tools and pipes like the tooling device, or the Pearl, which looks more like a fancy sewing machine, they operate a lot like a sewing machine. You would design your graphic on the computer, print it out on a piece of paper, spray paint it to a stack of embossing plates, two plates that were hinged, and then you would feed it. The operator would be very skilled and would feed it underneath a tooling device that would be going up and down just like a sewing machine, and would basically sew the lines onto the plates. And here on the left, I have a plate of some model from a model of the inner solar system to show you what was possible on the plate embossing devices, or the Pearl, really. And then if you had any symbols that had to go onto the embossing plate, you used a second machine that you can see there on the left that's called the Pearl Companion. And it basically puts symbols onto your plates, triangles, circles, those kinds of small symbols that were hard to make with the Pearl itself. But once you had these plates made, you could actually emboss them on almost any kind of press. Today, we do graphics much more sophisticated. We've got a machine called the Green Machine, which basically is a thermographic process. You print out your graphic, you spray some powder on it, and then you heat it up, and the powder raises. Or we could do it on one of the Rolands, which you design the graphic on the computer, and then it goes over everything 7 times, each time laying down a little more ink, and it builds up a nice relief. Then you take out the big roll, as you see there, cut them apart, and put them into a thermoform machine to make the final plastic page that's going to go in the museum. But this ability to make tactile graphics is one of the things that sets the printing house apart from a lot of other Braille shops in the United States. And then I just had to brag to show you our Vanguard UV flatbed, which we also use. And so it can be used to make tactile graphics, again, by just going over and over and over whatever it's printing on, or it can be used to paint the parts that go in our educational aids. So the Vanguard flatbed is a really awesome press, and it always gets a lot of attention when we bring people on tour. So to just kind of finalize my talk, which I know I've been running through a lot of stuff, but we are actually tearing our whole front of our building off, going to start this winter. We're going to build a new structure out in front of the original building here at APH. That's going to house our new museum. We're going to expand our museum. We're going to have a gallery that's going to be devoted to the Helen Keller Archive, and expand what we're able to show. And so what I've got on the screen right now is just an artist rendering of what that new building is going to look like. And it's going to open sometime around October of 2024. So we've got a lot on our plate. So I want to welcome you, if you're interested in any of the things I talk about, to friend us on Facebook and Twitter. Our address is @APH Museum, and we do a lot of little videos of a lot and talk a lot about the history of what I've talked about a little bit, and I can go into a little more detail. On the web, you can find our museum website at aphmuseum.org. And I want to just shill our 2022 Helen Keller Symposium that's coming up September 17th and 18th. You can find registration information on that at our museum website. And we're pretty excited about the lineup for that symposium. And I want to welcome everybody to come join us if you're interested in the history of education and rehabilitation for people that are blind or low vision. So thank you very much. And I think we're going to take some questions.
Thank you so much, Michael. That was amazing. That was really eye-opening and informative for me, at least. I see that we do have a few questions from the audience, and of course, I have about 1,000 questions as well. So let's start out with our guests. Remember, there's plenty of room for more questions, and upvote the ones that you want to see answered. So Jessica asks, are there diacritics for Braille fonts?
So everything that you can do in print, you can do in Braille, but the particulars of the way that the font the way that Braille is translated, I will have to admit I don't know a lot about. But like if you want to bold something or italicize something or underline something or put it in parentheses, all those things are possible. So I would imagine that the answer is yes.
Okay, you can. That is great. I'm going to stick my question in here because it's kind of related. Do you know what embossing systems exist for non-alphabetic writing systems?
Like give me an example of one.
Like Chinese logographic.
Okay, yeah, sure. So the Chinese and the Japanese use kanji, right? And there are too many. There are only 63 possible mathematical combinations of those 6 dots. So they do use the Braille system, but there are kind of 2 Braille codes for those alphabets. One, they put 2 Braille symbols together so that you get enough mathematical combinations to write it. Very few people in China and Japan use that system. Instead, there is also a phonetic alphabet that has been devised for both Japanese and Chinese, and it does fit in the 63, limitation. And so most Braille readers in China and Japan use that phonetic system to recreate their language. And if you're interested, you can go to the World Braille Union's website, and you can look at the Braille code for every written language in the world.
Okay.
So Arabic would be another example of that. There is an Arabic Braille code.
Right. Okay, that is amazing. Since Arabic is at least alphabetic, I could understand that it might work in a similar way, but
you're thinking about pictographic systems, yeah.
Okay, thank you for answering that. Let's see what else we have. Taylor asks, Mike, could you speak to the role, if any, played by blind students in the production of tactile books in the 19th century? Would Knies, for instance, have learned the trade while a student in Philadelphia?
Okay, so let me throw that out there. We need to know more about Napoleon Knies Jr. He's extremely significant, and we don't know much about him. We know that he was a student at Overbrook, which is the Philadelphia, which back then was called the Pennsylvania Institution for the Education of the Blind, and that after he's graduated, his father helped capitalize his print shop, and that he did a lot of work for the Pennsylvania school. What I don't know is, where did he pick it up? Did he work in the print shop at at the Pennsylvania school? He probably did, but I don't know that for a fact. So lots of other examples at the various schools of students who went on to work in the print shops at the schools. But my first example is of Awi's book and all of Louis's books. All of those were produced in the print shop at the School for the Blind in Paris by the students. So in brief, lots of examples of that. At the schools, if they had an embossing shop, a print shop, lots of kids would work in the shop, and then you would always tend to have, like, there's this guy named Arthur Jewell, who in Illinois' School for the Blind was especially known in the 19th and 20th century for producing Braille music. And Jewell was a kid who went there and then became the printer, the director of their print shop after he graduated. So yes.
Okay. So a lot of people basically learned the trade at the school.
At the schools.
Okay.
That's right.
Okay. All right. I did a brief answer for that. Ellen asks, what weight of paper would the Braille press use?
It uses 80 to 100 pound.
Okay.
Yes. And the reason it uses a heavyweight paper and we humidify the area is so that you get a nice, crisp, round dot that's enjoyable to read, that you can read again and again and again without flattening out the dot. If you use too thin a paper, the dot will flatten out. And if you let the paper dry out, the pins in the press will poke holes in the paper, and it will make after very little amount of time of reading it, it will abrade your fingertips and is very unpleasant to read. So if you want to talk sometime about the history of wetting paper, we can do a seminar on that.
Wow. Okay. Because I'm a letterpress printer, so some of the things you're talking about are familiar to me, but
absolutely. Absolutely. And the line between letterpress printing and early Braille embossing and large print, I mean, not large print, but raised letter printing are very similar.
Let's see. BZ asks, is modern Braille writing, as in a book or magazine, solely a character by character transliteration of the written English?
And the answer, yeah.
It is. Okay.
The answer is no.
Oh, okay. He asks, have there developed shorthands or other patterns unique to the Braille version that make reading faster, etc.? By the way, fascinating talk. Thank you.
Oh, glad. Thank you very much. So the answer is yes. So there's actually 3 Braille codes. Okay, we call them uncontracted, contracted, and then there's a grade 3 for extremely advanced users that's not very commonly used. But uncontracted Braille, it's 1-for-1, and you learn that in 1st grade, right? But then there is a whole system of contractions. Remember, there's 63 possible combinations of those dots. So you only need 26 for the letters of the alphabet, and then you need, 11 or so for the main punctuation marks. That leaves you a lot left over. And so when Louis initially publishes his code in 1829, there are no contractions. By 1837, when he issues his first revision of the code, he has introduced 11 contractions. So what is a contraction? It is a combinations of letters that we use together frequently, like ER or TH or CH, right? And so what that means is that the word is still spelled correctly, but maybe you use fewer symbols so that you can read it quicker or write it quicker. And you learn those contractions throughout your elementary and middle school years, so that by the time you get to high school, you know literally hundreds of ways to abbreviate the way you write to make it quicker to read and write, including this thing called short form words. So for every letter in the alphabet except A and O and I, there is an entire word that if you encounter the letter all by itself, it means, so C all by itself. So space, C space is can. F is for. And it's all those kinds of little common words that we use all the time. But of course, A, I, and O we use by themselves, right? So there's no short form word. Anyways, in short, yeah, there's lots of little rules for contractions.
Okay, great. Stephen Coles asks, are there any serious alternatives to Braille or campaigns to offer them? And I had a similar question, which was just that you didn't want to get into the war of the dots, but I was curious as to how Braille seems to have won out. And
It did.
As Stephen asks, are there any other competing systems today?
None. But it's a whole hour-long talk to talk about the war of the dots.
So Braille is it today.
Yeah, but if you're interested, type in the war of the dots and Braille in your Google search engine, and it'll come up.
Okay, and Braille. Okay. Yeah, an hour to talk about that at least. Okay. Okay, type in. Okay. So BZ asks again a follow-up. How are other typesetting elements generally represented? So italics, bold, underline, headlines, different sizes of type, etc.
So I'm going to give you an example from capitalization. Okay. So in a Braille cell, it's 3 dots high and 2 dots wide. And for conversational purposes, we label them 1, 2, 3 on the left and 4, 5, and 6 on the right. Okay. So in order to capitalize the first letter of a word, like in a proper noun, like in Grendel, it would be 6 dot and then the character for G, which is 1 and 2 and 4 and 5. So it takes 2 characters to capitalize a word.
Okay.
If I want to capitalize the whole word, it's 6 dot, 6 dot, and then the word. So if I want to capitalize all the letters of Grendel, it's 6 dot, 6 dot, and that tells you the next word is all capped. If I want to capitalize the whole sentence, I go 6 dot, 6 dot, 6 dot, and that tells you until you run into a punctuation mark that ends the sentence, it's entirely capped. And I can use similar types of notation to underline, italicize, and bold. Just little rules.
I'm so impressed. Okay. Gabby asks, for students looking to further their education or pursue a master's studying tactile graphics, what resources can you suggest?
Gosh, I'm going to have to say I don't know.
Okay, well, we'll have to look that one up. You might start by visiting your museum.
That's right. But yeah, so tactile graphics and designing tactile graphics is an art and not a science. I can just answer that. And so what I would have to do would be to go down to our production floor and find out what the educational background of our people that do our graphics designing. I'd have to find out what their background is. And in truth, I do not know. You know, one of the hardest things to learn how to do in a museum is to say, I do not know. So we like to make up answers, because we're supposed to know everything, but that one, I don't know.
We say, I don't know all the time. and then it spurs us to do research and find out.
Yes. But yeah, that's the essence of a good education, is not to teach you all the answers, but to how to find the answers. Yeah.
All right. Bertie has a great question for you, which is, there are a lot of female technicians in the photos you've shared, and yet it seems like their labor is hidden. I wonder if this hidden labor may be connected to the labor of blind people in the development of Braille. How have we decided whose names we remember when we think of the history of Braille?
He's absolutely right. Like if we trot out the names, at least certainly in the 19th century, of the people who were associated with this advance or that advance. It's almost always some dude, some white dude, right? But if you look at the photographic record, as this gentleman already sees, it's a lot of a lot of women workers, and they're probably being underpaid, working at a nonprofit company that is probably not paying top dollar on the salaries. If you come visit our operation today, it's a very diverse operation. We have lots of people with disabilities that work here. We have lots of women and people of color in positions of authority. We have people with disabilities in positions of authority. So I think everything that happens at APH mimics developments in broader industry. But he's absolutely right that if you just look at, who invented this, who invented that, some white dude, right? And that it wasn't that simple, right? There were other people involved, and their names are forgotten. So that's on us as historians to delve deeper, to tell the true story, the real story.
Excellent. Yeah, we like to do that around here, and recognize the people whose labor has gone unrecognized over the years, decades.
Yeah.
Let's see. So I'm going to stick a quick question from myself in here again, which is, you mentioned that the Braille made it not only easier to print and write and easier for students to read, but you said it also made it easier for them to take notes. So when were there must have been special typewriters invented, and when were they invented, and what did they look like?
Right. So the first writing tools are Louis called his tool a Braille slate. And so, we in fact, you can still buy a Braille slate from the printing house and from other manufacturers. It's just a little writing guide that has little rectangular windows in it that guide the placement of your stylus. But the first mechanical Braille writer, first successful one, was invented by that guy I mentioned named Frank Hall at the Illinois School for the Blind in around 1891, 1892. The first 100 devices were delivered from the Munson Typewriter Company in Chicago in 1892. And then almost immediately, then he developed that further into the stereotyper that allowed you to prepare embossing plates. So every Braille writer that has come along since then is directly related, developed from the Hall Braille writer.
Okay, and the Hall Braille writer, if I recall correctly, it had like six
keys and a space bar. That was it. And it was based on typewriter design.
Okay.
So it had a carriage like a typewriter. The paper went into the carriage, and the embossing head was fixed. And if you want to talk about Braille writer design, that's more of a 2-hour talk.
Okay, let's see. We got a couple more questions in the chat. We do have to cut off at 1:30, but please keep dropping your questions until that point. I have a quick answer for Sabus, who asks, is this interesting talk? Will it be uploaded somewhere? Sabus wants to rewatch it. Yes, no worries, Sabus. You will receive a link very soon after the end of the talk to recording of the talk. And all our talks are also hosted on our website, so you can always go to letterformarchive.org and rewatch any of the talks that we have done. And we also have a question from Ali Donnelly. How accessible is tactile graphic printing for someone interested in exploring the process?
How accessible?
Maybe we need a little more clarity on that question.
Yeah. I'm not sure exactly what she's asking.
Yeah, I don't know what they are trying to say. So Ali, if you don't mind expanding on that, I'm going to take this other question from BZ, who's been very prolific with the questions, and we appreciate that. This is slightly off the topic of printing, but what tools, machines, and software are Braille users using on a daily basis to writing or punching and reading?
So the most significant development happened in the 1970s with the invention of what are called refreshable Braille devices. So we call those Braille note takers today. And so you can connect your device to, and they're made by, several different manufacturers. Braille Note would be an example. Chameleon, Mantis are a couple that we make here at the printing house. But you could connect to your phone or your tablet or your computer using Bluetooth or via wire. And what that does is it raises pins into a matrix to create one row of Braille at a time. So you read a row, press a button, it gives you the next row. And what that allows you to do is, say somebody sends you a text, you could read it in Braille, you could compose your response in Braille, but when it goes back out, it would go out in print. And so it allows you to move back and forth pretty easily between print and Braille. You could compose an essay in Braille on one of those devices and then print it out on a standard, Xerox printer in print. So that's really one of the big devices that has come along in the last 50 years that'll allow a Braille user to move back and forth between the print world and the Braille world pretty simply.
Wow. Okay.
And if they're interested in that, all they'd have to do would be to put in Braille note taker into their Google search, and they will find more out about that.
Okay, awesome. Let's see. Okay, so Ali has refined their question, which is, how do you get access to the materials to create your own images?
So I can think of a couple of low-tech ways, and then there are some high-tech ways. Okay, so the printing house sells two low-tech ways to make tactile graphics. One is an aluminum foil that we also make a number of tooling. Is it correct to say tooling tools? That sounds dumb, doesn't it?
Tooling is a word like.
Okay.
Yeah.
So these are tooling instruments that you could use to make drawings on this foil that create raised line drawings, right? And create textures. So you wanted to make a map and you wanted the ocean all to have one texture. We make a tactile graphics kit that goes along with that. Then we also make a plastic tissue that's used with a drawing clipboard called a draftsman. And when you write on the draftsman with a like an awl or a stylus, it actually creates a raised line. So you could actually put a drawing underneath this film, this plastic film, which is clear, and you could trace out the outline of, say, a coloring book or something like that, and it creates a tactile line. So those are low-tech ways to do it, right? Then high-tech, there are actually online libraries of tactile graphics that have pre-created types of graphics that can be created on a Braille embosser, where it's the embosser is actually made to make digital Braille, but people have created these lines where it would use the dots instead of creating Braille, it would create raised line outlines. Yeah, and if she's and then if they want to follow up and say what's the address of those libraries, then I would have to say, email me and I'll find out for you.
Well, so do you happen to sell that kit online?
Yes. Yeah.
Oh,
so if you go to aph.org, you can find both the draftsman and those tactile graphics kits on our website for sale.
Okay.
Along with a lot of the other things that I've talked about.
Awesome. Okay. Let's see, we've got just one more, okay, one more question to answer here, and I think all mine got answered too. Pedro Amado asks, I remember trying out a font, APH font, for low vision readers, but was, sorry for this, kind of funky. Was it yours? What's the story behind it?
It was ours. It was introduced within the last 20 years, but we ourselves have not, and it was designed as a font for low vision readers using a magnifier, but we are not happy with it either. And right now we're working with a brilliant young man whose name I think is Riley Cran to design a new low vision font. So yes, that is ours. We are also not completely satisfied with it.
Okay, I probably butchered poor Riley's name, but
I think it's RILEYCRAN, Riley Cran, I think.
I didn't totally butcher it. That's
Yeah, he's a pretty smart cookie.
okay. Any last minute questions before we sign off? We'd have time for one more. BZ. Okay, wonderful. Oh, I see Stephen Coles has made a note that Riley Cran has visited Letterform Archive, probably in doing some research for this.
Yeah, Riley is convinced that he's going to change the world with his font. So I'm very impressed with that level of ambition. He is quite impressive fellow.
Okay, well, listen, I have to thank you so much for this absolutely fascinating talk that sort of balanced the embossed writing systems and then the machines that produce those systems. Your knowledge of history and just introducing us to this world has been fascinating. Thank you so much.
Thank you, Grendel.
And thank you to our audience for joining in. Please join us again in the fall for more Letterform lectures. Have a great day.
Bye-bye. Thanks, everybody.
Bye. Woo. That